Hello, this is Kenny Demershi. This is a Foresight video. We will demonstrate how to rotate and translate data, export a DXF, and text. So this data will be in an assumed coordinate system, and we can see that if we go to the coordinate tab. It's an assumed coordinate system, but we want to get it into a UTM coordinate system. And I've also actually, if we go back here, we will see at the bottom that I have imported. In the previous video, I imported some UTM coordinates. So what I want to do first is show you what I typically do to make the decision on how to rotate and translate. So I went through all of the geodatabases from 2011, 2012, 2013, 2014, and gathered up all the benchmarks, looked at the raw files to see what method of survey was done. And what I found was a bit interesting. The first year they just kind of sprayed it in, and I'll show you what that is in a few minutes. And then in the second year, 2012, they did a resection of the sprayed in data. And then in 2013, they did a resection of the sprayed in data. And in 2014, they sprayed in the two benchmarks they could find, which was benchmark 2 and benchmark 4. So I think what happened is in year 1, 2011, the data was probably a new crew, first year of champ. They didn't have a lot of confidence yet. Okay, and then that kind of reverberated through each year's data. So in 2012 they went out, they oh, things don't fit well, let's do a resection. 2013, yeah, we can't find what they did in 2012, so let's do a resection. And then, you know, it just kind of carried on from year to year. Things got worse every year. So okay, so the methods in the champ protocol, it says to occupy a benchmark and backside a benchmark. And the reason for that is you actually measure the line between the benchmarks. In this example in the upper left corner, you can see that each distance between each benchmark is actually measured. It's a very good way of getting a survey going. Okay, in the resection, you see that the actual lines between the benchmarks are never measured, which is poor surveying. It is sometimes necessary, but we say the resection is a last-ditch effort. And then the sprayed-in method over here in the lower left, once again, the lines between the benchmarks are not actually measured. That's why in the champ protocol it says occupy a benchmark, backside a benchmark. So the sprayed-in method is poor. So I sort this by description, and I can come down and all the benchmarks will be grouped together with the control points. In this case, in 2011, the crew surveyed, and then a resurvey was done in 2014. And in 2014, the crew could not get the benchmarks to fit properly. So what we do is kind of look through here and try to determine what they were able to find in 2014, and what they found is benchmark 2 and benchmark 4 here. And it's also indicated by 827 and 828. 828 is 2, 827 is 4. Okay, so those are the only 2 points they found in 2014. Everything else they set. So if we go back to the map window and we go to Kogo inverse and 827, 828, and solve. When we get a result, oh, yeah, we have the horizontal disk, but notice it's just to the nearest centimeter. That's not good enough. So you want to go File, Project Options, Units, Format, and change all of these to 3 decimal places. Exception being the angles. You want it the most precise possible. And then we'll solve again. And now we have significant figures that do us that are helpful. So 827 to 828 is 23.765. 0.7903 vertical. 27 is so let's go ahead and zoom in. So 827 to 8 is 4 to 2. And if we look at, we can use this button here to zoom to a point. So let's zoom to 4004, which is benchmark 4. So here's my UTM data out here. So I want to know is 2 to 4 the same distance in both coordinate systems? Well, let's find out. Solve. And if you look at the vertical, you can see vertical, they're within 6 millimeters. Horizontally, they're within, what's that? 7 centimeters. So it's not very good. It is actually the same point, and you know that because the vertical match is very close. Unfortunately, the horizontal doesn't match up well. But it's the only data we have. The only 2 common control points between 2011 and 2014 are benchmark 2 and benchmark 4. So we're going to have to rotate and translate based on benchmark 2 and 4, even though they don't fit very well horizontally. So this means that these are good enough to get our 2014 data into UTM, but probably not good enough to do a good geomorphic change detection. Probably going to end up with some large errors. And that's because the fit is not good, but also if you look at the spread of these benchmarks relative to the length of the reach, the benchmark geometry is very poor. And yeah, so if you wanted to know why, if you would look at the historical data, the site was basically this line right here has never been measured. So let's do the rotation and translation. What I'm going to do 827. Okay, so this is 4 to 2. Yeah, I think we're okay. Okay, I moved back over to the assumed coordinate system. What I'm going to do with this, these coordinates or inverses is make a report, and I'll just slide that to the side, because what I'm going to do is the rotation, and I will rotate from this direction to this direction. To do that, I go to Adjustments, Rotate, Translate, Scale. I'm going to zoom out a bit, and I'm going to do my rotation first. You have to pick a point of rotation. This will be 828. I usually do the change in direction because I have that information here. So original let's see what it's. Control C, Control V. You do have to edit to remove the degree symbol. The new angle or direction. Control V. Let's again edit that degree symbol out. Now this is south, east, northeast, rotating around 828. All these points aren't selected. Okay, they're selected now. So when I select rotate, everything will move. And I always do my rotation first, so that if I mess up the rotation, it's easier to fix. If I do the translation first, I have the new data on top of the old data, and I don't want that. Alright, it's not a bad idea to inverse again from 827 to 828. Solve, compare that. So north 11, 02, 43, 346. So it looks good. Okay. So I got my rotation correct. Now we'll do the translation. Translate from point, okay, it's 828. So if 828 is benchmark 2, that's 4002. That's benchmark 2 in UTM. And select the points. 828, benchmark 2, 4002, benchmark 2. Translate. So I can't see my data anymore. So let's go check it out. So this point, BM2, should be one and the same for 828 and 4002. I can't zoom in anymore. So there's one right on top of the other. So there's a bit of difference here, which should be our, what was it, 7 or 9 centimeters. And we can check that once again with our Kogo. Yeah, 7 centimeters. 5 millimeters vertical. Okay, we've done the rotation, the translation, and made it fit as best we could. It doesn't hurt to have a look around and see if any other points match up. So I wondered about these 2 points on this bar. It's probably a gravel bar out there. So I wondered if that's actually the same benchmark. And after Kogoing it, the answer is I doubt it, because it's over 2 meters away. So either it is the same benchmark with some really bad surveys, or it's 2 different benchmarks. So I just considered it not a good match to use for rotation or translation. Okay, now the exporting. File, export. So why would I export an ASCII coordinate? Because I have a raw file. Here's my raw file. Well, when you do a rotation and translation, it doesn't change anything in the raw file. So the raw file is still in assumed coordinates. So when you run this data set through the champ toolbar, it will compute assumed coordinates. So we're going to have to export the data, the points as txt. And then there'll be a separate video to show you how to bring in the txt UTM coordinates into the champ toolbar. And we'll call that non-conforming data. Okay, file, export, ASCII, point name, northern, eastern, elevation, description. Select your points. Another thing you'll want to do in this case, once you get a text file, is clean up all of these extra benchmarks and control points. So export, select where Foresight data sets. That's actually the correct address. So 2011. And you should know how to export the DXF. Nothing new there. I will often make these smaller, actually. So there you have it. Rotate, translate, and export. Thank you very much. Have a nice day.